construction of the largest airport in the world in Istanbul, Turkey, stands as a testament to the monumental undertaking of modern engineering and infrastructure development. Spanning a vast area and requiring extensive planning, resources, and manpower, the project aimed to establish Istanbul as a global aviation hub and contribute significantly to the economic development of the region and the country as a whole. From the procurement of raw materials to the deployment of cutting-edge machinery and the coordination of a diverse workforce, every aspect of the construction process was meticulously planned and executed to bring this ambitious vision to life. The journey of constructing Istanbul Airport began with the vision of transforming Istanbul's aviation landscape and enhancing its connectivity with the rest of the world. As Turkey's economic and cultural capital, Istanbul has long served as a bridge between Europe and Asia, and the construction of a world-class airport was deemed essential to accommodate the growing demand for air travel and to solidify Istanbul's status as a global hub. With this vision in mind, the Turkish government embarked on an ambitious project to build an airport that would not only be the largest in the world by area, but also set new standards for efficiency, sustainability, and passenger experience. One of the first and most crucial steps in the construction process was the acquisition and preparation of the site for the airport. Situated on the European side of Istanbul, near the Black Sea coast, the chosen location offered ample space for the expansive infrastructure required for an airport of such magnitude. However, preparing the site involved clearing vast stretches of land, leveling terrain, and ensuring proper drainage and infrastructure access. Environmental impact assessments were conducted to mitigate any potential ecological concerns, and measures were taken to preserve the surrounding natural habitats and ecosystems. With the site prepared, the next phase of the construction process involved procuring the necessary raw materials to begin building the airport's infrastructure. Concrete, steel, asphalt, glass, and various other building materials were sourced from both domestic and international suppliers to meet the project's demanding requirements. Concrete, in particular, played a pivotal role in the construction, serving as the primary building material for the airport's runways, terminals, parking facilities, and other critical infrastructure. Steel was used extensively for structural support, framing, and reinforcement, ensuring the durability and integrity of the airport's structures. Asphalt was laid down to create smooth and durable surfaces for runways, taxiways, and access roads, while glass adorned the terminal buildings, allowing natural light to flood the interior spaces and creating a modern and welcoming environment for passengers. Simultaneously, a massive workforce was mobilized to undertake the construction tasks, comprising skilled laborers, engineers, architects, project managers, and support staff. The workforce was drawn from diverse backgrounds and nationalities, reflecting the global nature of the project and the collaborative effort required to bring it to fruition. Local workers were supplemented by international experts with specialized skills and experience in airport construction, ensuring that the project adhered to the highest standards of quality, safety, and efficiency. To support the construction efforts, a vast array of machinery and equipment was deployed at the airport site, ranging from heavy earth-moving equipment to specialized construction vehicles and tools. Excavators, bulldozers, cranes, dump trucks, and concrete mixers were used to move earth, lift heavy materials, and pour concrete for various construction tasks. Advanced construction technology, such as building information modeling (BIM), GPS-guided equipment, and automated construction systems, was employed to streamline processes, improve productivity, and minimize waste. Skilled operators and technicians manned these machines, ensuring their efficient operation and maintenance throughout the construction period. The construction timeline for Istanbul Airport was ambitious, with multiple phases planned to accommodate the airport's gradual expansion and development. The initial phase of construction focused on establishing the essential infrastructure required for airport operations, including the construction of runways, taxiways, aprons, terminal buildings, and support facilities. Despite facing challenges such as adverse weather conditions, logistical constraints, and regulatory approvals, the project proceeded according to schedule, thanks to meticulous planning, proactive risk management, and effective communication among stakeholders. As the construction progressed, the sheer scale and complexity of the project became apparent, requiring innovative solutions and adaptive strategies to overcome various challenges. Construction teams worked around the clock to ensure continuous progress, with multiple tasks being carried out simultaneously to expedite the completion of critical milestones. Close collaboration between contractors, subcontractors, and suppliers was essential to coordinate logistics, manage resources, and resolve any issues that arose during the construction process. Throughout the construction period, stringent quality control measures were implemented to ensure that the airport's infrastructure met the highest standards of safety, durability, and functionality. Regular inspections, testing, and certification procedures were conducted to verify the integrity of structures, materials, and systems, with any deficiencies or discrepancies addressed promptly to prevent delays or compromises in quality. Additionally, environmental sustainability was a key consideration in the construction process, with measures taken to minimize waste, conserve resources, and mitigate the project's ecological footprint. Despite the challenges and complexities involved, the construction of Istanbul Airport proceeded with remarkable efficiency and effectiveness, thanks to the dedication, expertise, and collaboration of all those involved. The project served as a testament to Turkey's ambition, ingenuity, and capacity for large-scale infrastructure development, showcasing the country's commitment to positioning itself as a global leader in aviation and transportation. Upon its completion, Istanbul Airport heralded a new era of connectivity and prosperity for Turkey, serving as a vital gateway for international travelers, businesses, and cargo. The airport's strategic location bridging Europe, Asia, and the Middle East positioned Istanbul as a key transit hub, facilitating travel, trade, and investment across regions and continents. Its state-of-the-art facilities, modern amenities, and world-class services elevated the passenger experience, attracting airlines and travelers from around the world and bolstering Turkey's tourism industry. Furthermore, Istanbul Airport's economic impact extended beyond its immediate surroundings, driving growth and development in the broader economy. The airport created thousands of jobs during its construction phase and continues to generate employment opportunities in various sectors, including aviation, hospitality, retail, and logistics. Its role as a transportation hub and economic catalyst has spurred investment in infrastructure, real estate, and related industries, contributing to Turkey's overall economic resilience and competitiveness on the global stage. In conclusion, the construction of Istanbul Airport represents a remarkable achievement in the realm of infrastructure development, symbolizing Turkey's ambition, vision, and determination to build a brighter future for its citizens and the world. From its inception to its completion, the project exemplified the transformative power of strategic planning, innovative technology, and collaborative teamwork in shaping the built environment and driving sustainable economic growth. Istanbul Airport stands as a testament to Turkey's potential and promise as a global leader in aviation, commerce, and innovation, poised to leave a lasting legacy for generations to come. Pipeline maintenance and relocation procedures represent critical aspects of managing and ensuring the integrity, safety, and operational efficiency of pipeline infrastructure. This detailed exploration delves into the multifaceted processes involved in both maintaining existing pipelines and relocating them to accommodate evolving needs and environmental considerations. It encompasses a comprehensive overview of the planning, execution, and safety protocols inherent in these complex endeavors, highlighting the importance of proactive maintenance, thorough risk assessment, and meticulous compliance with regulatory standards to safeguard public safety, environmental health, and the longevity of pipeline systems. The maintenance of pipelines is a multifaceted process that encompasses a range of activities aimed at preserving the integrity and functionality of pipeline infrastructure. These activities include routine inspections, preventive maintenance measures, emergency response protocols, and ongoing monitoring efforts to detect and address potential issues before they escalate into safety hazards. Routine inspections serve as the foundation of effective pipeline maintenance programs, providing critical insights into the condition of pipelines and identifying areas in need of attention. Visual surveys are conducted to assess the exterior condition of pipelines, checking for signs of corrosion, damage, or leaks. Inline inspection tools, commonly known as PIGs, are deployed to assess the interior condition of pipelines, detecting defects such as cracks, corrosion, or metal loss. Cathodic protection surveys are conducted to evaluate the effectiveness of corrosion prevention measures, ensuring that pipelines remain protected against degradation caused by environmental factors. Preventive maintenance measures are implemented to mitigate potential risks and extend the lifespan of pipelines. These measures include coating maintenance to repair damaged or deteriorated pipeline coatings, cathodic protection system upgrades to counteract corrosion, and regular servicing of valves and pumps to ensure optimal performance. By proactively addressing issues such as corrosion, wear and tear, and mechanical failures, operators can minimize the likelihood of leaks, ruptures, or other failures that could compromise pipeline safety and environmental integrity. Despite proactive maintenance efforts, emergencies such as leaks or ruptures may still occur, necessitating swift and effective response measures. Leak detection systems, including automated sensors and monitoring devices, are deployed to detect and alert operators to any anomalies in pipeline integrity. In the event of a leak, containment and cleanup protocols are initiated to mitigate environmental damage and minimize the impact on surrounding communities. Shutdown procedures are implemented to isolate affected pipeline segments and prevent further leakage, ensuring the safety of personnel and the public. Pipeline relocation is another important aspect of pipeline management, driven by factors such as urban development, infrastructure projects, or changes in land use. The process of relocating pipelines involves comprehensive planning, risk assessment, regulatory compliance, and meticulous execution to ensure the safe and efficient transfer of pipeline infrastructure to new locations while minimizing disruption to communities and the environment. The process begins with thorough planning and preparation, including route analysis, environmental impact assessments, and stakeholder engagement to identify potential relocation routes and address concerns. Regulatory approvals and permits are obtained from relevant authorities to ensure compliance with legal and environmental requirements. Risk assessments are conducted to identify potential hazards and develop mitigation strategies to minimize risks associated with pipeline relocation activities. Prior to relocation, pipelines undergo preparatory measures to ensure structural integrity and operational readiness. Coating inspections are conducted to assess the condition of pipeline coatings and conduct repairs or upgrades as needed to prevent corrosion. Cathodic protection systems are tested to verify their effectiveness in mitigating corrosion risks. Pigging operations are performed to clean and inspect the interior of the pipeline, removing debris and assessing its condition. The execution of pipeline relocation activities involves a series of coordinated tasks, including excavation operations are conducted to expose sections of the pipeline for relocation while minimizing disruption to surrounding infrastructure and the environment. Specialized equipment such as cranes, hydraulic jacks, and pipelaying machines are used to lift, transport, and install pipeline segments at their new location. Welding and connection operations are performed to ensure the structural integrity and leak-free operation of the relocated pipeline segments. Pressure tests are conducted to verify the integrity of the connections and ensure compliance with safety standards. Throughout the relocation process, efforts are made to minimize environmental disruption and mitigate community impacts. Dust and noise control measures are implemented to reduce emissions and noise levels associated with construction activities. Traffic management protocols are enforced to minimize congestion and ensure the safety of workers and the public. Environmental monitoring is conducted to assess air and water quality, soil contamination, and wildlife habitats, enabling the implementation of mitigation measures as needed. In conclusion, pipeline maintenance and relocation procedures are complex undertakings that require meticulous planning, rigorous execution, and a commitment to safety and environmental stewardship. By adhering to best practices and leveraging advanced technologies, stakeholders can ensure the integrity, reliability, and sustainability of pipeline infrastructure for future generations. Continued research and innovation in pipeline maintenance and relocation will further enhance safety, efficiency, and environmental sustainability in the years to come.